Hello and welcome to Mr. Tompkins EdTech. This series of videos and their accompanying predicted papers are my best guess as to what you might expect in your next maths exam. This particular video covers OCR Paper 3. I've taken a look at what's already come up along with some statistical analysis of previous papers and drawn up a list of high frequency topics that have not yet been tested and are highly likely to appear in the coming paper. I've then selected some typical questions that you might expect to see on each of these topics and created a diagnostic paper for you to try. You'll find a link to this paper below, so why not pause the video and go and download it now. Got it already? That's great. The idea is for you to try these questions yourself first, then watch the video to mark and up-level your work. This should help you identify what topics you are solid on and, more importantly, which ones you still need to work on. In the description below the video, you'll find links to further resources on each of these identified topics. So once you've finished here, you can tap on these links to target any areas of weakness that you still might have. Also in the description, you'll find a list of further topics that may well also come up. Remember, I've only included the most likely here, but there will be others, and if you have time you should also work through those topics too. If you've not already subscribed and hit the bell, go and do it now. That way you'll be notified when I post more videos to help you succeed in your maths exams. Any questions, make sure you pop them in the comments below the video. Good luck with your preparations, and let's get into it. Round 32,629 to the nearest thousand. Well, the thousands are this digit here, aren't they? That's the thousands. The 3 is tens of thousands, the 2 is thousands, 6 is hundreds. So I need to round off after that too. That's the cut point. So everything after that cut line is going to get thrown away. But just before we do, we just need to check out the value of the next digit along, which is 6. And then if it's 5 or more, we need to raise the score. We're going to round up. If it's 4 or less, we need to let it rest. We're going to round down, and in this case it's 5 or more, so I'm going to round this one up, aren't I? So my 32 at the beginning is going to go one up. It's going to go 33. Now 33 is not a good estimate of 32,629. My rounded number has to have the same magnitude. That 3 at the beginning was tens of thousands, so we need to make this number tens of thousands again just by adding some extra zeros on the end. Okay, so just check your answer is the same magnitude as what it was to start with. 33,000. Next we need to round 32,629 to one significant figure. Now the first significant figure is the first non-zero digit of your number. That's the 3. Okay, so in this case we're going to be rounding off right after the 3. Okay. Now the next digit along is this time is a 2, which is 4 or less, so we need to let it rest. We need to round down in this case. Okay, so the 3 at the start is going to stay being a 3, and we're just going to then add on enough zeros to make our answer the same magnitude as it was to start with. So adding 4 zeros, I'm going to get 30,000. Okay, another way of thinking about it is the first significant figure is in the tens of thousand column. So just round your number to the nearest 10,000. So you can see that 32,000 is closer to 30,000 than 40,000. Well, a theme park asked 900 people to choose their favourite activity from a list of 5. The pictogram shows the result for 4 of the activities. So we've got thrill rides, family rides, entertainment, children's rides, water rides. And we can see here that this key to this is that like a little grid like this with 4 little cells represents 100 people. Okay, so then how many people chose entertainment? Well, if one of these represents 100 people, look, then in entertainment I've got 1, 2 of those, so that's going to be 2 lots of 100. It's going to be 200. Part 2 says how many more people chose the water rides than the family rides? Well, the water rides has got 2 whole of one of those grids, and then it's got this other weird one here. So this one, is, this grid is divided up into 4. So if each one of these grid is worth 100, then one of the cells within that grid is worth going to be 25 then, isn't it? So this is going to be worth 25, 25, 25. I don't think that line should be there. It kind of came out weird when I printed it. So it's actually just 3 of those things. So it's 25, 25, and 25. So that means that one there is worth 75, and that's worth 100, and that's worth 100. So altogether, that's 275, isn't it? Water rides is 275. Family rides, again, I've got one whole one, which is worth 100. And one of these quarter parts, which is worth 25, so that's 125, give me a 125 altogether. So how many more people? More means the difference between the two, doesn't it? So to find out how much more it is, I'm going to have to subtract one from the other. So 275 take away 125. That's got a difference of 150, isn't it? So that's 150. 150 more people chose water rides than family rides. And then finally, all 900 people chose one of the 5 activities. Complete the pictogram for the children's ride. So the children's ride hasn't been put in there. Okay, so let's just count how many we've got for the other rides. So we already worked out that entertainment was 200. We wrote that down for part A. And then thrill rides we haven't looked at yet, but that's got 100, 100, and 25 and 25. So that makes 100, 150. So that's 250, isn't it? So what we've got all together so far, we've got 250, 125, 200, and 275. That adds up to, well, you can type it into your calculator if you like. I'm just going to quickly do it in my head. 275, 300, 400, 500, 600, 850. So that adds up to 850. So if I then take 850 away from 900, 900 take away 850, that's going to be what's left over for the children's rides. That's 50. So to represent 50, I'm going to have to use half of one of these like little grids, aren't I? So not a whole grid, just like a half of one, like that. Okay, that should do the biz. So that represents 50. If I was in an exam, I'd probably use a ruler to draw those boxes, but you know, it's not so easy on my computery thing, so I'm just going to sketch it in today. Question 5, Lev, Maria and Nicholas, which we're going to denote with L, M and N, sit in a row of 3 seats. Use the table to list all the different orders in which they could sit. One possible order is already shown in the table. You may not need to use all the rows of the table. Okay, so we've got seat 1, 2 and 3, and the first arrangement is L, then M, then N. And we need to find all the other possible arrangements. Now, when you're listing things, my recommendation is to try and keep the first thing the same first. So for my next arrangement, I'm going to keep L the same at the front here, and then I'm going to switch these other 2 around. So these 2 are going to switch over and become N and M, like that. And now, are there any more arrangements with L at the front? Nope, that's all of them. I can have L, M and N, or L, N and M. So now that I'm done with L, I'm going to switch around and I'm going to start looking at M at the front. So I'm going to bring M to the front and draw it here. And then I'm going to do the same thing. I'm going to then do L and N here. Okay? I don't know why I'm color coding them. I just kind of got into the thing of it now, and I feel like I should continue. So then I'm going to keep M the same at the front, and then I'm going to switch those 2 around, N and L. Why did I start this? Okay. I just feel compelled to continue. And then so I've done all my M's, and now I'm going to bring N to the front, and I'm going to do L and M, and then N, M, L, and weirdly I'm just going to finish colouring them in because I don't know. There we go. So yeah, we've got 2, 4, 6 of those all together. All possible orders in which they could sit are equally likely. What is the probability that Lev sits next to Maria? So probability of L next to M. Now that's equal to successful outcomes divided by total outcomes. Okay, now the total outcomes are the fact that I've got 6 different arrangements. I've just worked them out in part 1. I worked out 6 different ways of arranging those 3 people next to each other. So that's the number on the bottom. Now the number on the top is going to be the ones that meet the criteria. How many of those outcomes do have Lev next to Maria? Okay, well, I can see Lev is next to Maria in the first one there. They've got Nicholas in between them for the second set, so that doesn't work. I've got Maria, Lev there, so they are next to each other. And then Nicholas sneaked into the middle again there in the third one and the fourth one, and then I've got them together over here, and they're together over here. Okay, so they're actually sitting together in 4 out of those 6 arrangements. It's only when Nicholas sneaked between them in the second and the fourth one that they were parted momentarily. So anyway, so it's going to be 4 out of 6. Now, you might feel the urge to cancel that down, but actually, you never get any extra credit for cancelling down fractions in papers. So, yeah, you can do it. You can if you want. It's not necessary. So 2/3 is the most simple version of it, but it doesn't tell me to specifically simplify. So you're not going to get any credit for doing that. Let's write the following numbers in order of size, smallest first. Okay, so I like to try and compare these digit by digit, moving from left to right. So now they all start with a 0. That's the same for all of them, isn't it? And actually, the next digit along is the same for all of them as well. Okay, they all got a 5 there. Then things get different on the next digit, don't they? So on the next digit along, we've got a 2, a 4, a 1, and a 0. And that's what I'm going to rank them on then. I'm going to rank them on that digit. So the smallest one first is the one with the 0 in it then, isn't it? So that's 0.502. That's my smallest one. The next one is going to be the one with a 1 in it. So that's 0.51. And then I'm going to look at the one with a 2 in it, which is 0.529. And then I'm going to look at the one with a 4 in it. So that's 0.54. Okay. So just make sure you're comparing like digits with like digits when you're doing these. Question 6. A shop sells the same milk in 3 different size cartons. The diagram shows the price of each carton. So you can buy it for 300 millilitres for 31p, 500 millilitres for 47p, or 2 litres for £1.96. Which carton is the best value for money? Show how you decide. Now, your kind of natural instinct would be the bigger one would be the cheapest, but shops, they're a bit naughty sometimes, and it doesn't always work out that way. So good to check. Now, to work out the best amount, we need to have a standardized amount. So it doesn't actually matter what that amount is. We could work out per milliliter. We could work out for a litre, or we could find something that it will go into. Now, the strategy depends on the paper. This is the calculator paper, so it doesn't really matter so much what number you pick. If it's a non-calculator paper, I'd probably pick a number that they all multiplied into, like a common factor or common multiple of those, a bit like you do with fractions. I'd be looking at 300 to 500 and 2000 and coming up with an LCM of those, and then maybe scale them all up. But because I've got my calculator here, it doesn't really matter so much. I'm just going to make it like, I think maybe a litre. So that should be fairly easy to do for each of them, especially for the last 2. The first one might be a little bit harder, but anyway, we'll get there. There's no problem. Right, so let's have a look at the 2 litre one. So the cost for 1 litre of that then, what is the cost of 1 litre? So 1 litre is going to cost £1.96 divided by 2, isn't it? Because you've got 2 litres in there. So if I divide it by 2, I'll get the cost of 1 litre. So what's 1.96 divided by 2? 1.96 divided by 2. So that costs 98p for 1 litre. Okay. Now for the 500 milliliter, if I double that one, I'm going to get a litre, aren't I? So 1 litre of this one is going to be what, 47p times 2 then, isn't it? So 0.47 times 2, that comes out to be 94p. See, Supermarkets, you got to watch them. 94p there. And then the 300 milliliter one for 31p. This was a little bit trickier to do. 1 litre here. What I'm going to do is I'm going to take 31p. I'm going to divide it by 3. That will tell me the price for 100 milliliters, sorry, and then I'm going to times it by 10. So I'm going to basically find 10/3 of 0.31. So 0.31 divide by 3 times by 10. That should tell me the cost of 1 litre. That is £1.03 reoccurring. So that's just £1.03 to the nearest penny then, isn't it? Okay, so you can see now, because I've got the same amount for each one, I've got 1 litre there, 1 litre there, 1 litre there, then I can compare the prices quite easily. So I can see here that the best value for money is that one there, isn't it, 94 pence. Okay, so which carton is the best value of money? 500 milliliter carton is best value. Now it says show how you decide. I kind of already did that. I'm not going to rehash it again. You know, my argument is a mathematical argument, and I've written it out here, haven't I? This is my argument here. I don't need to rehash it again into words. My mathematical argument stands. Part B says a student only buys milk on a Saturday morning. They use 120 millilitres of milk each day. Any unused milk is to be thrown away at the end of the following Friday. Show that it is cheaper for the student to buy milk they need in 300 millilitre cartons than in 500 millilitre cartons. Yeah, so whilst 500 millilitre is the cheapest per milliliter, if you're going to end up chucking a lot of it away, then maybe it isn't the cheapest way for you to buy milk. Maybe it's better to buy the smaller one. Let's just double check that. So they use 120 millilitres a day from Saturday through Friday. So that's 7 days, isn't it? Saturday, Sunday, Monday, Tuesday, Wednesday, Thursday, Friday. So their total milk consumption for the week then is going to be the 120 millilitres per day times the 7 days of the week then, isn't it? So 120 times 7 comes out to be 840 litres, 140 millilitres. Okay, so in order to have 840 millilitres of milk, then they're either going to have to buy 3 of those on any given day, or 2 of those. Okay, so that's enough, isn't it? 3 lots of 300 is 900 millilitres. Or I could do 2 lots of 500 millilitres, which is 1,000 millilitres. Either way, I've got enough milk for the week then, haven't I? Okay, now one less would not be enough. I suppose I could buy 2 of the 300 millilitres and 1 of the 500s, but I'm not sure that's not going to work out any cheaper, is it? So they're my 2 options. So either buys 3 lots of 300 millilitres, which is 3 times 31 pence, which is, what's that? 3 lots of 31, that is 93 pence. Or he buys 2 of the 500 millilitre packs, which is 2 lots of 47 pence. Which comes to, I suppose you put 0.47, and 0.47 times 2, that comes out to be 94 pence. So it's a penny more expensive. Okay, so at the end of the day, he's chucking away slightly less milk if he buys the 300 millilitres one, because he's only wasting 60 millilitres, plus he's saving a penny. So that's the better deal then, isn't it? If he's going to be not wasteful and also saving himself some money. Okay, so I'm just going to conclude cheaper to buy 300 millilitre containers. Jenny has a 5-sided bias spinner. The sectors are coloured red, blue, green, yellow and white. She spins the spinner 100 times. the table below shows the number of times the spinner lands on each colour. So the colours are red, blue, green, yellow and white, and you can see that they've landed on various colours various numbers of times. Jenny uses her data to estimate the probability of the spinner landing on each colour. Write down Jenny's estimate of the probability of it landing on red. Okay, so you can work out like a practical version of probability. We call it relative frequency. By taking the number of successful trials, which is in this case 28 for red, and dividing it by the total number of trials, which in this case is 100. So 28 divided 100, that is 0.28, isn't it? And so that is a rough and ready approximation of the probability of landing on red. Now obviously with 100 trials, probability being as it is, it might, the actual true value might be slightly more, slightly less than that, but it's going to be close to it. Okay, for part B, Jenny then writes in some of the colours on this probability scale. So she's written in yellow at 0, which is correct. Look, because yellow, there were 0 outcomes out of 100. So it's hard to believe that there was any yellow on there if none of them came up in 100 throws. So yellow is pointing at 0, which is impossible. Now the next one along is between unlikely and evens. If you think about this scale, there are how many jumps between one end and the other? So there's 1, 2, 3, 4, 5, 6, 7, 8. So each one of those is an eighth, or quarters in between, aren't they? So unlikely, that's at 0.25, that's at 0.5, that's at 0.75, and that's at 1. So this arrow is pointing somewhere between 0.25 and 0.5, and it's actually closer to 0.5. Well, halfway between 2.5 and 5 is about 0.37. So I'm guessing that must be the blue one then, mustn't it? Because the other two, the red and, well, the other three, the red, the green and the white, are going to be further down. They're going to be below, well, just a little bit above the 25, aren't they? 0.25, not all the way up here. Okay, so this one I think is going to be the blue one. Right, explain why Jenny's estimate for the probability of landing on yellow cannot be the actual probability. Well, if you remember at the start of the problem, it was described as a 5-sided spinner, bias spinner, so it's kind of weighted to one side. So when you spin it, it's more likely to land on one of the other colours than it is to land on yellow. But presumably, if yellow is one of the kind of corners of your spinner, if you think about the spinner, so it's kind of, maybe it's got like a weight on this side, which means if you were to spin it, it's more likely to fall this way. But you know, if yellow was over here on this side, it's going to be less likely to land on it, but it's not going to be impossible, is it? Okay, it's just going to be very, very unlikely, which is why she hasn't rolled on it already. I'm guessing that's the sort of answer they're looking for. So cannot be the actual probability. 0 would imply that it is impossible to get yellow, but as it is one of the sides of the spinner, it must be possible, although unlikely, to land on it. Okay, so that's my reason. Okay, so it didn't land on yellow in any of those because it does favour the other colours quite strongly, but presumably, you know, if there's some sort of freak wind, it might just kind of fall over onto the yellow at some point. Question 7. A survey asks whether some students went swimming or played tennis last month. We're told that 17 played tennis, 11 did not go swimming or did not play tennis, 22 went swimming, 8 went swimming and played tennis. Some of this information is shown on the Venn diagram below. Now notice they say some that means we need to go through it carefully and just double check what's on there and what isn't. Okay, so let's go through it line by line. First line, 17 played tennis. Now the tennis area of my diagram is over here, look, this bit over here, and you can see that already I've got 8 down in the middle, which are people who played tennis and also swam. So if there are 17 altogether, then in that section there, then there's going to be 17 minus 8. That's going to be 9 people in there, isn't it? Okay, so there are going to be 9 people in there. So let's just get rid of the yellow and put 9 in there. Okay, that's 9. I might get rid of that arrow as well. And then 11 did not go swimming and did not play tennis. So those who did neither go on the outside of the circle. So I'm going to write that this 11 here, I'm going to write outside here. Okay, so that bit gave me the 9 and that bit gave me the 11. And then 22 went swimming. Yeah, I kind of already had that down. Swimming is in here, look. And so the 14 and the 8 is already there. So I knew about that already. And then finally 8 went swimming and played tennis. Again, that was already there. That's the bit in the inset there. Okay, so yeah, some of it was on there and some of it wasn't. So how many students were in the survey then? So the students in the survey is everybody in the diagram, isn't it? Total students. And we're going to get that by adding all the various parts of the Venn diagram together. So there are 4 section regions of zones. I'm going to just add all the numbers of students in each zone together. So I've got 4 plus 18 plus 9 plus 11. What does that come to then? 9 and 11 is 20, plus 14 is 34, plus 8 is 42. So there are 42 students altogether. Question 8a, shape G is drawn on the grid. Yes, it is. Rotate the shape G by 180 about the point A. Now, I do recommend at this point you put your hand up in the air and ask the invigilator if this was an exam for a piece of tracing paper. And then you can just simply lay the tracing paper over the shape like so. I normally put a dot in each of the corners of the shape first. If you feel like it, you can then join them up with a ruler, but maybe it's not necessarily. Maybe you just rotate the piece of paper around with just the corners on, and that's where your new corners will be. Just as a top tip, I like to put like an X across at the center of rotation. And the reason for I do that is because as I rotate it around, I can see when I've turned 90 and 108 degrees. And so I know when to stop, okay, which is there. Okay, I'm going to stop there. And then so you can see where my new points are going to be. And then I can just kind of lift the tracing paper up a little bit and drop it down again and kind of work out where I need to put my points. So one of them is going to go here. One of them is going to go here. One of them is going to go here, and one of them is going to go here. Okay, and once you've got them all down, you can then get your ruler out and join them up. Do we need to label it anything? No. I'm just going to call it G dash because it's like the image of G. Okay, it doesn't tell me to label it, but they often do, so I just kind of label them anyway. Right, let's move on. Part B, shape H is drawn on the grid. Enlarge shape H with a scale factor of 2 and the center of enlargement at the point B. Okay, so when you've got a shape with a center of enlargement, then you can work out where all the other points go by drawing ray lines through each of the corners of your shape. Okay, so I'm just going to draw line going down here, line going across here, and a line going down here. Now the image point of your enlargement are just going to lie further along those ray lines. So this point B lies on the center of enlargement, so that isn't going anywhere. If a point lies on the center of enlargement, it's not shifted at all by the enlargement, it just stays where it is. Okay, now this next point over here, that, I hope you can see, is 1, 2, 3 units away from the center of enlargement. Now the scale factor is 2, so I need to multiply that distance by a factor of 2. So rather than it being 3 units away, it's going to be 6 units away from the center. So we've already gone 3, so that's 4, 5, 6. So the point is going to end up there. Okay, that's where the new image point is going to be. Let me just get rid of these jumps. Okay, so it's not messing up my diagram. So that's one of my points. So one of my original point at B is staying at B. Then I've got a point at that point over there. Let's have a look at this point down here then. Oops. Let's have a look at this point down here next. Okay. Now this point lies like 2 units down and 1 across from the center of enlargement. So if you were going to double that distance, rather than being 2 down and 1 across, it's going to be 2 times 2. It's going to be 4 down, and 1 times 2, it's going to be 2 across. So it's going to be here on the ray line. Okay, so it's twice as far away. Another way of thinking about it, look, that diagonal line and that diagonal line are the same. So it kind of works out, doesn't it? Okay, so that's where the point is. Again, I'm going to get rid of these extra dotty dots that I drew, just so I keep the diagram tidy. And then finally, I've got this point here on my diagram. Now that is 1 unit down, 2 units down and 2 units across. So its image point is going to be 2 times 2 is 4 units down and 4 units across. It's going to be here. Okay, so now I've got all of my corners mapped out. I can now join them up with straight lines. And again, don't try and enlarge the lines, enlarge the dots. This is the way. Now once you're done, you should know, I mean, it should look right, shouldn't it? Your new shape should just be like a bigger version of the shape you had. If it looks different, you've done it wrong. Okay, so just use your eyes at the end to double check what you've got looks just like a bigger version of the shape you started with, which mine does. Okay, it's a trapezium, it's still a trapezium. It's still just a bigger version of that same shape. Okay, I'm done. The diagram shows the scale drawing of a sandpit ABCD. It also shows the arc of all points in the sandpit that are 80 centimeters from the corner A. We're told that the scale of 1 centimeter represents 20 centimeters. A game is played by throwing a ball into the sandpit. Points may be scored when the ball lands in the sandpit. 1 point if the ball lands within the 80 centimeters of corner A. And 1 point if the ball is closer to side AB than to side AD, and 1 point if the ball is closer to corner A than it is to corner B. By completing the construction, find and shade the regions where 2 points can be scored. Show all of your construction lines. Right, now the first construction is already done for us, isn't it? So the one where it has to be within 80 centimeters from corner A, that circle has already been drawn. It's that arc, isn't it, there? Yeah, so you can see this one is 4 centimeters, which is 80, so that has already been done. So I'm going to move on to the second one, which says 1 point if the ball is closer to side AB than AD. Okay, so the construction that we need for the points that are equidistant from 2 lines is the angle bisector of those 2 lines. Okay, so what we're going to have to do is construct the angle bisector. Now normally I would put the compass at A first and do an arc that cuts both, but we've already got this handy arc already drawn, so I'm just going to use those 2 points to mark my cross in the middle to make the angle bisector. Okay, so that makes my job a little bit easier. So sticking on either end, we're drawing a little arc, and then where they cross, that is going to be where my angle bisector is going to go through. Okay, so the line I'm drawing are all the points that are equidistant away from those 2 lines. So clearly if I want it to be closer to AB, then I want it to be below that line there then. Right, next construction. The point of if the ball lies closer to A than to B. So the points that are equidistant from 2 given points A and B are going to be the perpendicular bisector of that line. Okay, so in order to draw a perpendicular bisector, I'm going to set my compass to a little bit over halfway between those 2 points. And I'm going to draw an arc with the compass based at B. Okay, a bit of a semicircle going on there, and then switch over to A, and I'm going to draw another semicircle. We should find that they meet in two places. Okay, it's a little bit off screen. Let me just push it up a bit. So drawing a line through where those two arcs crossed, that's going to be my perpendicular bisector. So all of those points are equidistant from A and B. Okay, so if we want the points that are closer to A, then I want the points to the left of that line. As I said earlier, if I want the points that are closer to the line AB than the points AD, then I want those below the angle bisector. Okay. Now in this case, I then want the ones outside of the circle then, because if it's inside the circle, it'll be worth 3 points. But I want to highlight the ones that are just worth 2 points. So inside the circle would meet all 3 conditions, and then they'd be worth 3 points. Now, is there any other place which is worth 2 points? This one here is, isn't it? Because that's inside the circle and closer to A than to B, so that's worth 2 points. What other regions have we got? This one up here is only worth one point because it's closer to A than B, but doesn't meet any of the other conditions. And the one down there is worth 1 because it's closer to AB than AD, and the one at the top is worth 0 because it doesn't meet any of the conditions. Right, so they're the 2 regions that I want, and I've shaded both, so that's job done. Let's move on.
Jack and Liam each get the same pocket money. Jack spends 75% of his and has £2 left. Liam spends 40% of his. How much does Liam have left? Well, if Jack spends 75% of his and he gets and he's got £2 left, then 25% is what he has left, isn't it? And that is equal to £2. So if 25% is equal to £2, then 100% is going to be 4 lots of that, then, isn't it? Okay, and 4 lots of £2 is £8. So that means that Jack must have had £8 pocket money to start with. Now we know that Liam has the same amount of pocket money, so he must also have £8. So if he spends 40%, then he's got 60% of his pocket money left. So what we need to do is to find what 60% of 8 is. So using our triangle, final, original, multiplier. Our final is what we're trying to find. Our original is £8, and our multiplier, let's say we want to find 60%, don't we? 60% of the amount, which has a multiplier is 0.6. So to find our final, just cover that up, is original times multiplier. Final is equal to original times multiplier. So 8 times 0.6, which is, according to my calculator, 8 times 0.6 is 4.8. Now remember, this is money though, so we're going to have to write that as pounds and pence. So he's got £4.80 left. Now you could have also found out what 40% was and deduct it from the £8 to get the same answer if you wanted to, but this way is quicker if you know what you're doing.
Sandip is going on holiday. She wants to change £400 into euros. Bank A will change her £400 into 452 euros. Bank B changed £250 into 280 euros for Sandip's friend. It will use the same rate to change Sandip's £400 into euros. At which bank will Sandip receive the most euros, and by how many? Show your working. Okay, so we know what's going on in Bank A. We just really need to work out what's going on in Bank B, don't we? Now Sandip's friend took £250 and she changed it into 280. So we can use those two figures there, that one and that one, to work out the exchange rate. So the exchange rate is going to be, well, let's take the 280 and divide it by 250, and that will tell me how many euros I'm going to get for each pound. Okay, so the exchange rate is 280 divided by 250. That comes out to be 1.12, which is basically £1 then is going to get you €1.12. Okay, so then if I then have £400 to change, I'm going to take my €1 and 1.12 euros and I'm going to times it by 400, and that's going to give me 448. Okay, so 448 euros from Bank B. Now we got 452 from Bank A. So Bank A is going to give her the most. Okay, by how much? Difference is going to be what she got in Bank A, 452, minus what she gets from Bank B, 448. And that comes out to be 4. So Sunday received €4 more. Okay, might buy her a, drink at the bar or something. Ben and Sundip are making pancakes using the ingredients below. Ingredients to make 12 pancakes: 75 milliliters of water, 200 milliliters of milk, 100 grams of flour, 50 grams of butter, and 2 eggs. Now the ratio of the amount of water to the amount of milk needs to be 75 to 200. Write this ratio in its simplest form. So if I've got a ratio of 75 to 200, these cancel down pretty much the same way as fractions do. You've got to look for common divisors that you can divide through by. Now I know that 75 and 200 are both divisible by 25. So if I divide both sides by 25, if you don't spot 25, you might spot 5 and then do it a second time to cancel it down a bit more. But I could see that 75 had 25 in it, so yeah, I could do it straight away. So 25s into 75 go 3 times. You've got 4 25s and 100, so you're going to have 8 and 200. So that cancels down to 3 to 8. Okay, so I think that's in its simplest form. 3 is prime, and it doesn't go into 8, so 3 to 8 is our simplest form. Part B says Ben makes 18 pancakes. Work out how much flour he needs. Okay, well, if I make a ratio of pancakes to flour, then I know from the original recipe that for 12 pancakes we needed 100 grams of flour. So I can write down 12 to 100 here. Okay, now what I want to do is change 12 pancakes to 18 pancakes. Now I can't just multiply 12 by something to get 18, okay, but I can go by a stepping stone to make the maths a little bit easier. So if I first find out how much it is to make 6 by dividing by 2, I can then scale that up by a factor of 3 to find 18. I think that's going to work easier with my 100 on the other side, isn't it? So on the other side, if I divide 100 by 2, I'm going to get 50. So for 6 pancakes, I need 50 grams of flour. And then taking that 50 and scaling up by a factor of 3, then 50 times 3, that's 150. So for 18 pancakes, I need 150 grams of flour. Okay, then Sundip has 225 grams of butter and 10 eggs. She has plenty of the other ingredients. Work out the maximum number of pancakes that she can make. So which one is going to be the limiting factor? Is she going to be more limited by the amount of butter, or is she going to be more limited by the amount of eggs? Okay, well, at the moment, we know that pancakes to eggs is 12 pancakes for 2 eggs. So then if I wanted to, if I have 10 eggs, that's 5 times as many as that, isn't it? Okay, so 5 times 12, that gives me 60. So I've got enough eggs to make 60 pancakes. But that might not be the limiting factor. I might be limited on the butter. So let's just double check the butter as well. So for the butter, we've got 12 pancakes it requires 50 grams of butter, and we've got 225 grams. Okay, so again, it might be helpful to go by a stepping stone, because 50 doesn't go directly into 225. But if I halve it first to get 25, then I can easily scale it up to 225 after that. So dividing 50 by 2 will tell me how much pancakes I can make with 25 grams of flour. So that's 6, isn't it? I can make 6 pancakes if I divide 12 by 2. I'm going to get 6. And then taking 25 and scaling it up, how many 25s go into 225? Well, it's going to be 4, 8, 9 times, isn't it? So I times that by 9. I should know that gives me 225. So doing times it by 9 on the other side, 6 times 9, that's 54. Okay, so I've got enough eggs to make 60 pancakes, but I've only got enough butter to make 54. So that's going to be the limiting one, isn't it? You know, I've got enough. If I've got enough eggs to make 60, then I've got enough eggs to make 54. But if I've only got enough butter to make 54, then I don't have enough butter to make 60. So 54 is the maximum I can make then, isn't it? So 54. Question 11, here's a function machine. I've got an input. My input value is multiplied by 4, and then 3 is subtracted to get my output value. So find the output when the input is 10. So when I put 10 in here, then 10 is going to be fed into my function. It's going to be multiplied by 4, and that's going to give me 40. And then if I then subtract 3 from it, I'm going to get 37 then, aren't I? So 10 goes in, 37 comes out. Okay. Find the input when the output is 17. So if the output was 17, then working back here, so if 3 was subtracted from it and I got 17, at this point here I must have had 20, mustn't I? Okay, and then if my number was multiplied by 4 to get 20, dividing it by 4, that gives me 5 then, doesn't it? So 5 went in, it was times by 4 to get 20, 3 was subtracted, and then that's 17. So the answer is 5. Okay, the input is x and the output is y. Write an equation for y in terms of x. Okay, right, so let's think this through. If I input x, then the first thing that happens to it is it's multiplied by 4. So that's going to give me 4x in the middle stage. And then after that, 3 is subtracted. So I'm going to get 4x minus 3. Okay, so x is the input and y is the output. So the y then is going to be that 4x minus 3 then. So the equation is going to be y is equal to 4x minus 3, like that. Question 16. The volume of a piece of wood is 620 centimeters cubed. Its density is 0.85 grams per cubic centimeter. Work out its mass. Okay. So again, we've got another triangle that we can use for density. Lots of these handy triangles. Density is mass over volume, isn't it? Okay. So dmv. So what's what then? So our density we've been given as 0.85. So that's 0.85 grams per cubic centimeter. Okay, and then we've been given the volume. Okay, so the volume is 620 centimeters cubed. Just really should check that the units match up. They do in this case, centimeters cubed and centimeters cubed. And we want the mass, of course. So we're going to cover up the thing that we want to find, mass. And then it tells us what to do with the other two. So mass equals density multiplied by volume, which in this case is 0.85 times by 620. Okay, what's that then? 0.85 times 620, that's 527. And that's my answer then, 527 grams. height h of a lorry is 4.3 meters, correct to one decimal place. Complete the error interval for the height h. Okay, now I like to do these with the number line. I draw a number line and I mark on the number that they've given me, which is 4.3. Okay, so then we know it's correct to one decimal place. If I was drawing a scale and that was going up in numbers to one decimal place, then the next one up on the scale would be 4.4, and the one below it would be 4.2, wouldn't it? It'd be 4.2, 4.3, 4.4. Now, the numbers that round to 4.3 are going to be the numbers that are halfway between 42 and 43 or nearer, or halfway between 43 and 44 or nearer. So basically, this range of numbers are the numbers that round to 43, aren't they? Okay? But what number is halfway between 42 and 43? Well, I know that that is 40, not 42 and 43, 4.2 and 4.3. It's 4.25. If you're not sure, you can just add the two numbers together and divide by 2, and that would tell you on your calculator. And the other one then is going to be 4.35. That's halfway between 4.3 and 4.4, isn't it? Okay, so my lower bound is going to be 4.25 and my upper bound is going to be 4.35. So any numbers between 4.25 and 4.35 round off to 4.3 to one decimal place. Question 17. The table below shows the area in square kilometers squared of some countries. Now you can see these areas have been given in standard form. There's a number times the power of 10, isn't it? Write the area of Sweden as an ordinary number. So in the table, Sweden is given as this, 4.5 times 10 to the 5. Okay, so 4.5 times 10 to the 5. If I want to write it as a normal number, I could just type that into the calculator and work it out, or I can work out where the decimal point goes. Times 10 to the 5 will have the effect of shifting the decimal point 1, 2, 3, 4, 5 jumps along. It will go to here, okay, which means there are going to be some extra zeros appearing in here. So my answer is going to actually be 450,000. What's that? That's 450,000, isn't it? Okay. The other way of thinking about it is 10 to the 5 is hundreds of thousands. 10 to the 6 is millions, isn't it? Okay, so that's 450,000. Part B says, which of the countries has the smallest area? Well, the smallest area is going to be the number with the smallest power of 10, isn't it? So if you have looked down those lists, you should know already that Luxembourg is a pretty teeny tiny country, and so is Singapore. So it's going to be out of those two, but if you look, 10 to the 2 is smaller than 10 to the 3. It's definitely Singapore. Singapore is just a teeny tiny island. Part C, Alexa says the area of Australia is approximately 3 times larger than the area of Luxembourg. Is she correct? Show how you decide. Well, just from common sense, I know she is ludicrously wrong. Australia is huge. But anyway, let's look at the maths. So you might think, if she was looking at this, she might be thinking, well, 2.59 times 10 to the 3, which is Luxembourg, isn't it? That's Luxembourg. If you just have a look at the mantissa part, the number at the front, then if you took 2.59 and times it by 3, you would get something around 7.69, which is the mantissa part of Australia. But Australia is 10 to the 6. So that is nowhere close. So Alexis is wrong. And the way you can do that, you can just maybe divide one by the other, can't you? So if you type into your calculator 7.69 times 10 to the 6 divided by 2.59 times 10 to the 3, it will tell you how much bigger one is compared to the other one, won't it? Now, to do that on your calculator, you want to be using the times 10 to the x button down at the bottom here. So when I type in the Australia one, I'm going to type in the mantissa part, 7.69, and then I'm just going to press that key there once. That's going to give me the times 10, and then I'm going to put in the power, which is 6. So 7.69 times 10 to the 6, divide by, then the second mantissa, which is 2.59, and then I'm going to press that 10 to the 6 button again, and I'm going to put in the power, which is 3. Okay, and that comes out to be 2969. So that's equal to 2969 and change. Okay, so Alexa's wrong because Australia is almost 3,000 times bigger than Luxembourg. Okay, you don't have to write equal if you don't want to. Right, so Australia is almost 3,000 times bigger. I didn't write my 3 very well either there. 3,000 times bigger than Luxembourg there. Okay, work out the total area of Russia and Australia. Give your answer in standard form to 2 significant figures. Okay, so I'm going to add these two together. Again, it's a calculated paper, so I'm just going to use the calculator function to do it. So 1.71 times 10 to the 7 plus Australia, which was 7.69 times 10 to the 6. So again, I'm just going to use that calculator button on the for powers for standard form on the calculator. 1.71 times 10 button. Type in the power, which is 7, plus 7.69 times 10 button. Type in the power 6, and that comes out to be 2479.0000. So that's equal to 2479.123 zeros. Okay. Now, what is that in standard form? What's it in standard form? Okay, so in standard form, the decimal point is currently here. So if I was going to move it between the 2 and the 4, it would go 1, 2, 3, 4, 5, 6, 7 jumps, wouldn't it, over to there? So that means it is 2.479 times 10 to the 7. But that's not 2 significant figures, is it? That's 4 significant figures. So to round it to 2 significant figures, I'm going to round it off after the 4. Next number is a 7, so I'm going to round it up. That makes it 2.5 times 10 to the 7 to 2 significant figures. Okay, so I just rounded it off there. 2.5 times 10 to the 7. Okay,
so 3x minus 8 is equal to 19. Okay, so I've got 3x minus 8 is equal to 19. Now, if I want to solve it, that means to find the value of x. So we need to get x by itself. Okay, now I can do that firstly by adding 8 to both sides. That's going to get rid of that 8 on that side, because negative 8 plus 8 is 0. So that is going to give me 3x is equal to 19 plus 8, which is 27. And the next thing I can do to try and get x by itself is to try and divide both sides by 3. Then 3 divided by 3 is just going to leave me with the x, and 27 divided by 3 is 9. So that tells me that x is equal to 9. That's my final answer, 9. That gives us a distance time graph showing the journey of a toy train. And underneath we have 4 possible descriptions of the first 2 parts of the journey. Now let's have a look at the first 2 parts of the journey. This first part here is a straight line, and it is increasing as time increases, so it's sloping upwards. So that indicates that the toy is moving at a constant speed. And then the next part, the distance isn't changing for a period of time, so that would indicate that the toy train is at rest. So which one of the descriptions most accurately displays that? So it must be B, moves at a constant speed and then is stationary. Okay, for part B, it says work out the average speed for the last 4 seconds of the journey. So average speed, if you remember your ST triangle. Average speed is equal to distance traveled divided by time taken. And from our diagram, the last 4 seconds is this part of the graph. Well, we know the time. The time is the 4 seconds. So this is how much time it takes, 4 seconds. And the distance traveled then is going to be the distance from 4 to 10, which is a distance of 6 meters. So it's gone 6 meters in 4 seconds. So then average speed then is going to be our 6 divided by 4, which is 3/2 meters per second. Question 20. Luke is an office receptionist. Each day for 60 days he records the number of people visiting the office. So then on 20 days there were between 0 and 5, 14 days between 5 and 10, 11 between 10 and 20, and 15 days when there were 20 to 40. Calculate the estimate of the mean number of people visiting the office. Okay, so we've got 2 empty boxes on the end. Now this is for our mid value, mid n, and this is my f times n column over here. So mid n is halfway between these two. Because I don't know the actual number of people, we'll use the midpoint of the range to estimate it. So 5 plus 0 is 5, divided by 2 is 2.5. So the mid value of 0 to 5 is 2.5. Between 5 and 10, 5 plus 10 is 15, divided by 2 is 7.5. 10 plus 20 is 30, divided by 2 is 15. And 20 plus 40 is 60, divided by 2 is 30. Okay, so they're my mid values. And then what we need to do is multiply those by the frequencies. Okay, so I've got 20 times 2.5, that's 50. I've got 14 times 7.5, that's 105. I've got 11 lots of 15, that comes to 165. And I've got 15 times 30, that comes to 450. Okay, then we need a couple of totals in here. Well, I already know the frequency adds up to 60. It tells me this, isn't it? It should add up to 60. If it doesn't, you can always add it up there. And I need the total over here. 50 plus 105 plus 165 plus 400 and, was that 450? Yeah, that comes to 770. Okay, and then so our estimated mean is estimated because we rounded off we estimated the mid value for each of the people in the range, didn't we? So estimated mean is going to be our total 770 divided by our number of people, which is 60. So 770 divided by 60, that comes out to be 12.83, which I'm going to round off to 12.8 people. Okay, so a little bit over 12 people per day came to visit. Part B says, Luke says the range is 40. Explain why he may be wrong. Well, he's got 40 from the highest minus the lowest value there, isn't he? Okay, but we are assuming, he's made the assumption then, that there were 0 people who came and there were 40. Now, it might be that you know, there could have been a minimum of 5, couldn't there? And they've all gone in the 0 to 5 category. Because we don't know the actual numbers in those two groups. We don't know for sure that there was a day where there was no people and there was a day that there was 40 people. Okay? So, because we have grouped data, we cannot be sure there was a day when 0 people visited and 40 people visited. Okay, I think that will do. I think that's clear enough. Question 21. Solve x squared minus 4x minus 165 is equal to 0. Okay, so I'm going to see if I can solve this by factorizing first.
Factorising would go into two brackets like this. Let's hopefully it does, because it's a lot easier than using the formula. So if it does, then it will be this number here we need to look at first. We need to find all the factor pairs of 165 and see which one I can get 4 out of for the middle term. So 165, what are the factor pairs of 165? Well, I've got 1 and 165, obviously. 2 doesn't go into 165. Does 3? Yes, it does. You can tell if a number divides by 3. If you add the digits together, 1 plus 6 plus 5, it comes to 12. Now, if what you add together it divides by 3, then your original number does as well. So 3 does. It's 3 times 55, isn't it? 3 55s are 165. Does 4 go in? No, because it's odd. Does 5 go in? Yep, because it ends in 5. 5 times what is 165? That's going to be 33. 33 times 5 is 165. Any more? Does 6? No. 7? Does 7 go into 165? No. 8? No. 9? Does 9 go into 165? I don't think so. Same trick as before. If you add the digits together, you get 12. 12 does not divide by 9, and so 165 doesn't either. So does 11 go into 165? Yes, it does. 11 goes in 15 times. 12, no. 13, no. 13, no. 14, no. So I think that's everything. I made myself come back down the other way. I think I can see which one it is anyway, because there's only one there that is 4 apart. It's that pair there, isn't it? It's that 11 and 15 that is going to be my solution. So I'm going to make it's negative 4 in the middle, so that means my bigger number needs to be the negative 1 and my smaller one must be the positive 1. So I'm going to make x plus 11, x minus 15 equals 0. Okay. Now if two brackets multiplied together give you 0, it means that one or other of the brackets must be equal to 0. So let's assume that the first bracket is equal to 0. X plus 11 is 0. So that means x is equal to minus 11. Or it could be that x minus 15 is equal to 0, in which case x is equal to 15. So there are my two solutions then. Either x is minus 11 or x is positive 15.
Has helpfully given us the formula for the volume of a sphere, which is 4/3 of pi r cubed. And we're told that a still sphere has a radius of 9 centimeters. So from here to here is 9. Work out the volume of the sphere. So this is just really subbing into that formula. So volume is equal to 4/3 pi r cubed, which is 4/3 of pi times 9 cubed. It's a matter of really typing that into the calculator. So 4 divided by 3 times by pi times by 9 to the power of 3. I make that 3053 and change. So I'm just going to, I'm going to round off 3053. I'm just going to round off to the nearest whole unit. Which would be 4 then, wouldn't it? In part B, we're told that the density of the steel is 7.8 grams per cubic centimetre. Work out the mass of the sphere. Well, density, the formula for density is mass over volume. So rearranging that, so make mass the formula, and mass the subject, sorry, and mass equals, we're going to take this and cross multiply it up here. So mass equals density times volume, which in this case is going to be our 7.8 grams per cubic centimetre multiplied by, just checking the units all the same, yeah, that's in centimetres, so 3054. Now I've still got the stored calculator value on my calculator, so I'm just going to carry on using that. So I'm going to take the answer and I'm going to times it by 7.8, and that gives me 23,818.
Complete the table for y equals x squared minus x Okay, now with these tables that you need to complete, the easiest way is to use the table mode on your calculator if you've got a Casio. If you don't have a Casio, you really want to get one of these because they've got lots of features that are very handy for your exam that you miss out on otherwise. So if you tap on mode and go to table, then you get f of x is equal to displayed on your screen. So it uses a slightly different notation. F of x is the same thing as y basically. So y is equal to, and then we just type in the bit on the other side of the equal sign, x squared minus x. Now to type in the x, you need to press the alpha key, and then the x here is above the bracket. So x squared minus, and then alpha x again. Okay, so x squared minus x. Press enter. You're going to get g of x appear. Now we've only got one function to type in this time, so we can leave that one blank for now, and then press enter again. Then the start value is going to be, well, I would go for either look at the table. If it gives you an x value, fine. If it doesn't, then what you can do is just look at the x-axis on your diagram and then pick out the number on the far left and the far right as your start and end values. So I'm going to be starting at -2, going to be ending at 3. Now the step is what we're going up in this case. You can see here we're going up in ones, so we're going to go up in ones, and then press enter. You can see I'm going to get a nice table displayed with all the values in that I need. Okay, so on my table then, the first box is -2 goes with 6, so I'm going to put in my -2 in there, and then I've got -1 goes with 2, so -1 goes with 2, 0 goes with 0, which matches, 1 goes with 0, 0, 2 goes with 2, and 3 goes with 6, so the rest all matches. Okay, so we filled out the table, and that was really easy. Just make sure you use the table because it does make life a whole lot easier. Part B, the graph of y equals x plus 1 is shown on the grid. It's already drawn. On the same grid, use part A to draw the graph of y is equal to x squared minus x for the values of x from -2 to 3. So basically we just need to plot those points, and don't we? Okay, so -2 goes with 6, -2 goes with 6, so that's a point there. -1 goes with 2, 0 goes with 0, 1 goes with 1, 2 goes with 2, and 3 goes with 6. Okay, now this is a quadratic curve. It has a nice smooth parabola between the points, and that's what you're going to be drawing on this shape. Okay, so it's a curving thing. Should be symmetrical on both sides. Now it doesn't have a flat bottom, so it will dip below the axes between 0 and 1, and then start coming back up again. Okay, now try and do a smooth line. It doesn't matter if it's a little bit wobbly, okay, but what you shouldn't have is feathering, so not multiple lines, and you need to try and skew at each of your points, so do try and go through each of the points you plotted. Okay, so a little bit of wiggle is not important, but you know, nailing the points and not doing multiple lines between points is that's what you're going to actually lose mark for. Now the last point says write down the x coordinates of the point where the two graphs cross. Now you can see they cross in 2 places. They cross here, look, and here. Now we want the x value, so if I just get a ruler and I read down to the axes, it's probably the easiest thing. Over here. Okay, so the first one looks slightly to the right of like a -1/2, but only ever slightly, and so I'm just going to leave it as -0.5, and then the other one is slightly to the left of 2.5, but not enough for me to change the value again, so I'm just going to put in -0.5 and 2.5, so -0.5 and 2.5. Okay, and I think we're done. Question 7. Sam types a constant number of words per minute. He takes 8 minutes to type a report of 416 words. How long does it take him to type an essay of 1,534 words? Give your answer in minutes and seconds. Okay, so I think what I'm going to do is just going to convert minutes into seconds to start with, because otherwise it's going to be difficult to calculate with. So 8 minutes, I can just type that into my calculator actually. So 8 times 60, that's 480 seconds, isn't it? So I can write that as a ratio, can't I? So if I do time to words as a ratio, so I know then it took him 480 seconds to produce 416 words. Okay, now I want to know how long it's going to take him to produce 1,534 words. So I can use something called the unitary method and go via 1, okay, by dividing by 416 and then multiplying by 1,534. If I do the same thing this side, so 480 divide by 416, okay, that comes out to be, well, 15 over 13. I might just write it down as 15 over 13 because it'd be quicker. So 15 over 13, and then multiply that by 1,534. I get 1,770. Okay, so that means it takes 1,770 seconds in order to type that amount of words. Now, what's that in minutes and seconds? So to convert that into minutes and seconds, I'm going to divide it by 60. Okay, now that's probably going to give me a horrible answer. Oh no, not that horrible. But then if I then press the hours, minutes and seconds button over here, you can see it's going to convert it into 2930, which is 29. So that's going to give me 29 minutes and 30 seconds then as my answer. 3 straight lines are shown. Work out the value of x. Okay, well, they aren't just any old 3 straight lines, are they? We've got 2 lines here that have got arrows on them, which means that these are parallel lines, and we've got a line crossing them. And where have we got that situation going on? It forms various angles, and there are relationships between various angles that are formed. Firstly, if you have a think about that angle there, it is vertically opposite this one, which means that those two are equal. So that one must also be 2x plus 15. And similarly, this angle and this, so that one and that one are equal, but also that one and that one must be equal because they are what we call corresponding angles. So in other words, 2x plus 15, that angle up there must be the same angle as 3x minus 38. Now they might look different because they're written algebraically using different expressions, but if they're the same angle, then these two algebraic expressions must actually be equal. So if we equate them like that, we form an equation in x that we can then go on to solve. Firstly, we've got x's on both sides, so let's simplify it a little bit by subtracting 2x from both sides. So if I take 2x from that side, they'll disappear. And if I take 2x from the other side, it's going to leave me with 15 is equal to x minus 38. Okay, now all I need to do is add 38 to both sides. You'll see that minus 38 plus 38 are going to cancel each other out, leaving you with x on the right, and on the left 15 plus 38, that's 38, 48, 53, isn't it? That tells me that x is equal to 53. In the diagram, DC is parallel to AB. So DC is this line here, AB is this line here, and you can see that they are parallel. Okay, so I've got a pair of parallel lines. It's not a parallelogram. Looks a bit like one, but those other 2 lines are not parallel. Now it asks me here to show that the triangle ABD is isosceles. So where's ABD? ABD is ABD, this triangle here, that's the triangle I'm looking for. And I need to show that it's isosceles
In other words, I need to either show that the lengths of two sides are equal. I'm not going to be able to do that. Or I can show that this angle and this angle here must be equal to each other. Okay, so I know the angle at the top is 124, so I need to show that this angle here then and this angle here are going to be isosceles. Are going to be equal to each other and therefore isosceles. Okay, so how am I going to do that? Well, let's have a look at the other triangle first, the triangle BCD, which is, I'm making a bit of a mess of this diagram, it's this triangle over here, look. Okay, so the blue triangle, I know 2 out of 3 of the angles from the blue one. I've got 152, so the angle at the top there, this angle up here, is going to be, well, the angles in the triangle add up to 180 degrees, don't they? So my 100 plus my 52 plus my angle there equals that angle there, doesn't it? So I know that that angle is equal to 180 minus the other 2. So it's going to be 100 plus 52. 100 plus 52 is 152. So 180 minus 152, what's that equal to? So 180 minus 52 is 180 minus 150 is 30, and 30 subtract 2 is 28. So that angle there is 28 degrees. Okay, so I know that one's 28. How's that helping me? Well, when you've got a pair of parallel lines and a line crossing them, then the angle there and the angle there we call alternate, don't we? And we know that alternate angles are equal. So that angle is going to be the same as that one down there. So on this diagram, that 28 is going to be the same as this angle down here then, isn't it? That one there is 28 because they're alternate. So I now know that that angle there must be 100, that is 28. So then this angle up here then, again, is going to be 180 subtract the other 2. So 180 subtract 124 plus 28. So 124 plus 28 is what? 124, 144, 152, isn't it? 180 minus 152. Oh, look, that's equal to 28 as well. That's also equal to 28. Okay, so we've shown then that both angles are 28 and therefore is isosceles. So we can say that angle ADB is equal to angle ABD, and that's equal to 28 degrees. So triangle is isosceles. Okay, done.
Mr. T, he's the best.